Good morning everyone. Today I am here to explain the basics of circuits, schematics, resistance and overloads. Let us explore the world of circuits together. An electric pathway that allows an electrical current to flow from one place to another is referred to as a circuit. For a circuit to be complete, the current must have a starting point and an ending point at the same location. If there is a gap, or break, between the 2 points, an open circuit is formed and no current will flow. On the other hand, if there is no gap or break, it is a closed circuit, allowing an electrical current to pass through it. This is the foundation of all types of circuits. When connected in parallel, each device has its own pathway for the current to flow through. This type of connection is used in applications where it is necessary to maintain near constant current flow to multiple different devices in the circuit. As each device has its own resistance, the total resistance of the parallel circuit is equal to the reciprocal of the sum of the individual resistances within the circuit. In a series circuit, the total resistance is equal to the sum of the individual resistances of each device. Moreover, Ohm's law is applicable to the entire circuit as well as each device included in it. Consequently, the current passing through all parts of the circuit is identical. A parallel circuit has devices connected between the same 2 points. Unlike series circuits, where devices are connected one after the other, the voltage across each branch in a parallel circuit is the same. The total current in the circuit is determined by the addition of the current in each branch. As the number of branches increases, the resistance in the circuit decreases, which results in a greater total current. Parallel circuits offer an advantage compared to series circuits, as even if one device fails, the rest of the circuit will continue to work. This provides a higher level of reliability, as opposed to in series circuits, where a malfunction in one device leads to the failure of the whole line. This concept can be applied in a wide range of contexts, such as medical equipment or home appliances, to guarantee that the items in the circuit stay functional. Schematic diagrams allow us to easily represent and understand the components and design of an electrical circuit. These diagrams demonstrate the relationship between components through simple symbols. For example, a line represents a connecting wire, a rectangle is a battery, a zigzag line is a resistor, 2 parallel lines with a gap is a capacitor, a rectangular box with a diagonal line through it is an open switch, and 2 parallel lines is a closed switch. Schematic diagrams are a useful tool for illustrating electrical and electronic systems. This illustration presents 2 examples of schematic diagrams. The first consists of 2 series 3W resistors in parallel with a 1 mF capacitor, connected to a 12 volts battery. The second shows 3 parallel 2 mF capacitors connected in series to a 10W resistor and 1.5 volts battery. Analyzing these schematic diagrams can help you make sense of complex electrical and electronic systems. We have 2 schematics. The first one consists of 2 series resistors connected in parallel with a capacitor, all of which are connected to a battery. The second schematic has 3 capacitors connected in series to a resistor and the same battery. Remember that the current will always take the easiest path, which means that when calculating equivalent resistance or capacitance, you must first determine which components or elements are in series and/or in parallel and account for this in your calculations. The equivalent resistance of a circuit is the value of the single resistor that would replace all of the other resistors in the circuit and still produce the same level of resistance. An example of this would be a circuit with 3 resistors of 8W each, which can be combined to produce an equivalent resistance of 8W. Combining resistors into a single equivalent resistance is an essential concept in electrical engineering design. The circuit before us consists of 3 resistors, each with a resistance of 8 ohms. To calculate the equivalent resistance, we must first determine if it is a series circuit or a parallel circuit. For a series circuit, the equivalent resistance is the sum of the individual resistances. For a parallel circuit, the equivalent resistance is the reciprocal of the sum of the reciprocals of the individual resistances. After determining which type of circuit it is, the equivalent resistance can be calculated. Using Ohm's law and Kirchhoff's law for resistors, the equivalent resistance of the circuit can be calculated. With 3 resistors in parallel, the total resistance of all parallel connected resistors is equal to the reciprocal sum of the reciprocals of all the branches. Therefore, the equivalent resistance of the circuit is equal to the reciprocal of the sum of the reciprocals of each of the resistors. Power dissipated by a 24,000 ohm resistor when a voltage of 120 volts is sent across it is 72 W, which can be derived from the formula power equals voltage to resistance. Applying the given values of voltage and resistance, the power dissipated is 72 W. Electricity from the power utility usually supplies 110 volts to 120 volts of power when it arrives at a wall outlet. Parallel circuits use wires with low resistance to enable the connection of multiple devices to a single source. When more devices are interconnected in parallel, the total resistance is decreased and the current rises, leading to an overload of the system. This can make electrical components overheat and may trigger hazardous and expensive fire hazards. It is important to comprehend the wire and load limits of a circuit before joining several devices in parallel. An overloaded circuit occurs when the amount of current flowing through it surpasses the safe amount for the line. This can cause safety hazards and damage to the line and any devices connected to it. To prevent an overloaded circuit, the total current in a parallel circuit must not exceed the capacity of the lines. A short circuit happens when damaged insulation or malfunctioning parts in a circuit allow electrons to travel through alternate paths, circumventing the normal resistance of the circuit. This leads to an abnormal increase in electric current, which can pose a fire hazard. To prevent short circuits, make sure all wires, gears and components are properly insulated and free of any damage. A potentiometer is a variable resistor, frequently found in many household devices. Operation is done by rotating a disc, altering the length of the resistor and subsequently its resistance. This type of device is very useful in many occasions and a fundamental tool for comprehending the circuits which have been discussed in this presentation. Appreciate your attention.